In this lesson, we will learn how to tackle questions involving populations where each member of that population has three related criteria. In the questions shown here, we have a population of students, and the three criteria are taking or not taking physics, taking or not taking sociology, and taking or not taking music. To solve this question, we will first draw three overlapping circles to represent the three subjects. In the blue circle, we will place students who are taking physics. In the yellow circle, we will place students taking sociology, and in the red circle, we will place students who are taking music. Notice that within this diagram, we have 8 different regions, which we will label A to H. Our goal is to place each of the 100 students in one of these regions, depending on each student's characteristics. Take region B, for example. Notice that region B lies inside the blue physics circle, and it lies inside the yellow sociology circle. It does not lie, however, within the red music circle. So students placed in region B will be students who are taking physics and sociology, but not music. What about region G? Well, region G lies inside the red circle, but it does not lie inside the other 2 circles. So students placed in region G take music only. Alright, what about region A? Well, this region lies inside all 3 circles, so students placed in this region take all 3 courses. Finally, what can we say about region H? Since this region does not lie inside any of the 3 circles, students placed in this region do not take any of the 3 courses. Now, the question provides information about the number of students with certain characteristics. For example, we are told that 60 students take sociology. So if we examine the regions within the yellow sociology circle, we can see that it consists of regions A, B, E, and D. Since the question tells us that a total of 60 students take sociology, we can conclude that the sum of the regions A, B, E, and D must be 60. Similarly, we are told that 36 students take physics and music. So we are looking for the regions that lie in the blue physics circle and the red music circle. If regions A and C consist of students who are taking physics and music, then we know that A plus C must equal 36. Now, an important point to make about these 8 regions is that they represent all possible configurations with regard to taking or not taking each course. So in this example, the sum of all 8 regions must be 100, since there are 100 students altogether. Okay, now that we have a good idea of how this diagram works, let's start filling in some numbers. When doing so, we will begin with the middle region, or as close as possible, and work our way outwards. So in this diagram, region A is in the middle, and it consists of students who are taking all 3 courses. So let's find the information about students taking all 3 courses. Well, the question tells us that 6 students take all 3 courses. So we know that in region A, there must be 6 students. Now that we have taken care of the middlemost region, let's work our way outwards. Next, we are told that 7 students take physics and sociology. So if we examine the regions that lie inside the blue physics circle and inside the yellow sociology circle, we can see that these 2 regions represent students who take physics and sociology. As such, the sum of these 2 regions must be 7. Since one region already contains 6 students, the other region must contain 1 student. Next, we are told that 46 students take sociology and music. Since these 2 regions represent students who take sociology and music, the sum of these 2 regions must be 46. Since one region already contains 6 students, the other region must contain 40 students. Next, we are told that 36 students take physics and music. Since these 2 regions represent students who take physics and music, the sum of these 2 regions must be 36. Since one region already contains 6 students, the other region must contain 30 students. Now that we have filled in the next innermost regions, we will tackle the outer regions. First, we are told that 40 students take physics. So all of the regions in the blue physics circle must add to 40. At this point, we know that 3 of the 4 regions add to 37, so region F must contain 3 students. Next, we are told that 60 students take sociology. So all of the regions in the yellow sociology circle must add to 60. We already know that 3 of the 4 regions add to 47, so region E must contain 13 students. Finally, we are told that 80 students take music. So all of the regions in the red music circle must add to 80. As such, region G must contain 4 students. At this point, we have determined the number of students in every region except region H, our target region. Now, earlier in this lesson, we found that all 8 regions must add to 100 since there are 100 students altogether. So we can use this to see that the sum of all 8 regions here must be 100. When we solve this equation for H, we get H equals 3. So there must be 3 students who do not take any of the 3 courses. Okay, let's summarize. In this lesson, we learned that if we have a population where there are 3 criteria associated with each member, we can solve the question by first drawing 3 overlapping sets. Then we fill in each region beginning at the middle and moving outwards. In this lesson, we will take an introductory look at sequences such as the 3 shown here. For the purposes of this lesson, we will say that a sequence is simply an ordered list of numbers. Now, as you can see, these 3 sequences each have dots at the end, which indicate that each sequence continues indefinitely. While it's true that not all sequences go on forever, you will find that the sequences found on the GRE are typically infinite. Now, the numbers that make up a sequence are called terms, and they are usually denoted using notation something like this. So in the bottom sequence here, term 1 is 7, term 2 is 10, term 3 is 13, and so on. Here's another sequence, and this time the terms are denoted a little differently. For example, in this sequence, the first term is term 0. On the GRE, some sequences will begin with term 1, and others will begin with term 0, so watch out for this. Now, some sequences are such that every term is clearly defined by some formula. So we can use this formula to find the value of any term in the sequence. Let's use the formula to find some terms in this sequence. Now, since we are told that the formula is valid for terms where n is greater than or equal to 0, let's begin by finding the value of term 0. To do this, we will plug n equals 0 into the formula to see that term 0 equals 2. Next, to find the value of term 1, we will plug n equals 1 into the formula to see that term 1 equals 5. To find the value of term 2, we will plug 2 into the formula to get 8. Using the same process, we can see that term 3 equals 11, and we can continue using the formula to find the value of any term. Since we now know the first few terms, we can see that the sequence looks something like this. Now, in this example, we are given a formula that can be used to find the value of any term in the sequence. Such a formula will not always be provided. For example, in this question, we are told that each term in the sequence is 7 greater than the term before it, and we want to find the value of term 41. To get an idea of how this sequence looks, let's use the fact that term 1 equals 3 to find some other terms. Now, if each term is 7 greater than the term before it, then term 2 must equal 10, term 3 must equal 17, term 4 must equal 24, and so on. Now, using this information, how do we find the value of term 41? Well, there happens to be a formula for finding the value of terms in this type of sequence, but I'd rather not look at it since it is often applied incorrectly. Instead, we can determine the value of term 41 by getting a clear picture of how the terms in the sequence behave. To do this, we need to look at the terms a little differently. To begin, we already know that term 1 equals 3. Now, term 2 equals 10, but I want to look at it differently. Since each term is 7 greater than the term before it, we can find the value of term 2 by taking the term before it, term 1, and then adding 7. Similarly, to find the value of term 3, we can take the term before it and add 7. To find the value of term 4, we take term 3 and add 7. Now, if we continue this pattern, we can see that term 41 will consist of 3 plus several 7s. So all we need to do now is determine how many 7s are added together in term 41. To do this, let's see if we can spot a pattern. First, notice that term 1 has 0 7s. Term 2 has 1 7 in its sum. Term 3 has 2 7s in its sum. And term 4 has 3 7s. Now when we continue this pattern, we can see that term 41 will have 40 7s. So to find the value of term 41, we must take our 3 and add to it 40 7s. This is the same as taking 3 and adding 40 times 7. This is equal to 283, so term 41 equals 283. Okay, let's summarize. In this lesson, we learned the notation used for sequences. We learned that some sequences on the GRE are accompanied by a formula that we can use to find any term in the sequence, and we learned that some sequences are not accompanied by such a formula.